Right. So now, good morning, students. So I think this is the second class I'm taking for you. So in the first class, the most of the students were absent. So I would like to repeat the same class which I've conducted in the last session. So here you can find the diagram building services too. So in that one, what you're observing there. So here, so from the generation of electricity, so what is happening? The electricity is given to the is transmitted by the transmission system, and after transmission system, again the electrical energy is distributed to the consumer by the distribution system. So distribution system forms the main part of the this electricity. So whatever the electricity that has been generated, so it has to be transmitted. Later, it has to be distributed to the consumers. So in the diagram, what is happening? So you can find that. So electricity is generated and it is transmitted via the transmission lines. And after the transmission, the electrical energy is being distributed to the consumers through the distribution system. So now you can define the distribution system as that part of the electrical system which forms the mediator between the transmission system as well as the consumer point. So that is called as the distribution system. So now let us look at the other diagram. So in that one, it's clearly indicating the various stages of the transfer of the electrical energy. So what you're finding there, generation. Are you able to hear everybody?
Yes, sir.
Yes, sir.
Right.
Yes, sir.
So are you able? Screen is clear now.
Yes, sir.
Screen is clear.
Yes, sir. Yes, sir.
Right. So here, so what is the generation? So as you all know, so electrical energy is generated at various kinds of power plants, and so like thermal power station, hydroelectric power station, tidal power station, like that. So various power stations will be there. So at those power stations, the electrical energy is generated generally, and next comes the transmission part. So in the transmission part, what is happening? So it forms a link between the production as well as the usage. So whatever the link that is there between the you can say production as well as the usage, that link we are calling it as a transmission. So here in the case of the transmission, you can find that electrical power is carried at a high voltages over longer distances. That is in this transmission part. So what is happening? The electrical power is transmitted at a very high voltages over longer distances. So that part of the system is called as what? The transmission system. So next comes the substations. So after the electrical energy has been transmitted to the substations, so you can find in the diagram. So what you're finding there. So from the substations, uh, the electrical energy is given to the bulk consumers as well as the normal consumers. That part is called as what here? The distribution system. So in the distribution system, what you are doing is, so transmission lines, whatever the power that is taken from the transmission lines is reduced to lower voltages, right? So in the case of the distribution system, what is happening? Whatever the electrical energy that we have taken from the transmission system, so it has been stepped down to lower voltages at substations, and that power is distributed to the consumers. So that part is called as what here? The distribution system, right? So the distribution system is nothing but what? So whatever the electricity from the transmission lines is reduced to lower voltages, and that low voltages are given to the consumers. So that is called as a distribution systems. So these are the three stages of the what you can say transfer of the electrical energy. First one is generation, second one is the transmission, and later comes the distribution system. So that is about the distribution system. Now coming to the layout. So that is the layout diagram of the distribution system. So what you're finding there. So in that layout, if you go through that one, so initially you have the this is the extension of the previous diagram only. So here generation system is there where the electrical energy is generated. Next comes the transmission system. So from the generating station, the electrical energy is being given to the transmission system, and from the transmission system we are giving it to the bulk power substations. So from the bulk power substations, you can find that. So electrical energy is going to where actually? So you can find that. So electrical energy is going for the industrial substation, and as well as the distribution substation, and also it is going through the sub transmission system to the distribution substation. So here, these are all the what you can say systems that are coming out through the bulk power substation. So in the case of the industrial substation, the voltages coming out of the industrial substation will be in the range of 12.47 to 13.8 kV. Okay, so whatever the voltages that are coming outside of the industrial substation are what? 12.47 to 13.8 kV. Similarly, from the distribution substation, the voltages coming out are what? It is ranging from what? 12.47 to 34.5 kV. And similarly, other distribution substations are there where the output voltages of those distribution substations are what? Primary system, which is ranging from 4.16 to 34.5 kV. So these are all the various output voltage of the distribution substations. So from the industrial substation, if you see, the voltages which are coming out of the industrial substations are ranging from 12.47 to 13.8 kV, and this industrial substation is especially meant for meeting the large industrial loads. So whenever the large industrial loads are there, so for those industries we require a very high amount of voltage. So that's why they'll have their own substations, and we call those substations as industrial substations. And are able to listen everybody?
Yes, sir.
Everybody following now?
Yes, sir. Yes, sir.
Right.
Yes, sir.
Yeah. Any doubt so far? Any doubt so far?
No, sir, no.
Right. So now from the industrial substations, the output voltage is ranging from 12.47 to 13.8 kV. So these industrial substations are mainly meant for meeting the large industrial loads. So large industrial load means, so whichever the what you can say large industries are there, for those industries you require a very high amount of voltage. So for that purpose, we will have the separate substations called as the industrial substations. And similarly, we have the distribution substations where the output voltage is ranging from what? 12.47 to 34.5 kV. And this distribution substation will again given to the load substation. So where in this load substation, so what is happening here? The output voltage is ranging from 480 volts to 4.16 kV. So in this load substation, again the voltage is stepped down to low voltages, which is 480 volts to 4.16 kilovolts. And again we have the one more distribution substation where the output voltage from this distribution substation is given to the distribution transformers. So where the voltages are ranging from 4.16 to 34.5 kV, and from these distribution transformers, the output voltages will be so you can observe there 208 by 120 or 120 by 240. So these voltages generally given to the commercial loads or the residential or rural loads. So this is the overall layout diagram of the, what you can say, the distribution systems. Right. So now, so whatever the previous diagram is there, so that we can easily understand by this diagram. So here generation voltage is there, so which is at a voltage of 11 kV, and by means of the step up transformer, what we are doing is we are increasing the voltage to 220 kV, right? And that 220 kV voltage is generally called as what? Primary transmission high voltage, right? So at the generating station, generator voltage is 11 kV only, Later, what we are doing is we are stepping up by making use of the step up transformer from 11 kV to 220 kV, right? So that 220 kV voltage is called as a primary transmission high voltage. And again, after transmitting to over longer distances, that is given to the receiving station, where the receiving station will have a step down transformer. So that step down transformer will stepping down the voltage to 220 kV to 33 kV, right? So in the case of the receiving station, so in the receiving station we have the step down transformer which will step down the voltage from 220 kV to 33 kV, right? So now again, what is happening? This 33 kV voltage, whatever it is there, is being transferred by means of the feeders. So this transmission where it is carrying a voltage of 33 kV, that is called as a secondary transmission system, right? So previously we have seen the primary transmission where it carries a high voltage of 220 kV, and in this case it carries a voltage of 33 kV, which we are calling it as a secondary transmission system. Right. So after the voltage secondary transmission system, what it is doing, it is giving to the substation. So in the substation, again, we have a step down transformer where it will step down the voltage from 33 kV to 6.6 kV, right? So this substation, whatever it is there, it generally having the step down transformer. So where it is going to step down the voltage from 33 kV to 6.6 kV, right? So this 6.6 kV, generally, if you observe, some industries will require very high amount of voltages. So for those industries, the 6.6 kV voltage is directly given. So that's why we have mentioned there. So to large or bulk loads like factories or industries. So whichever the large loads or bulk loads are there. So from the substation itself directly, we are giving power to the industries with at a voltage of 6.6 kV. Okay, so here again from the secondary of this distribution from the substation. So again we are giving to the distribution substation. So here, whatever the link that is there between, whatever the there between the substation as well as distribution substation, that forms a primary distribution, right? So what is primary distribution? Whatever the distribution system that is there between the substation as well as the distribution substation, so that we are calling it as a primary distribution. So in this primary distribution, this being carried by the feeders. Again, coming to the distribution substation. So in the distribution substation, what we have is, we have the distribution transformer. So in the distribution transformer, again, it is step down transformer. So here, the input to the this particular distribution substation is at a voltage of 6.6 kV. So by in the distribution substation, by means of the this particular step down transformers, will stepping down the voltage to 6.6 kV to 400 volts or 230 volts. Okay, so either we are stepping down the voltage to 6.66 from 6.6 to 400 volts or 230 volts. So that is about the what you can say distribution substations. Now coming to the from the distribution substation, from the secondary of the distribution substation, so we are giving it to the distributors. So whatever the system that is there between the distribution substation and distribution, that is called as the secondary distribution. And from the distributors, by means of the service mains, what is happening? The power is given to the consumers. So this is the overall what you can say transfer of the electrical energy from the generating station to the consumer point. So here the main thing you need to understand in this diagram is what is the primary transmission voltage, what is the primary distribution voltage, what is the secondary transmission, secondary distribution. So these voltage levels are very important while writing the answers. So you need to keep it in mind. So what is the primary transmission voltage means, what you can say, it is the 220 kV volts. Similarly, secondary transmission voltage means what you can say, 33 kV. So these are all voltages which you need to keep it in mind while writing the answers. Is everybody clear with the diagram layouts?
Yes, sir.
Yes, sir.
Understood now?
Yes, sir.
Any doubts so far?
No, sir.
Right. Now, let us see what are the contents that are going to be covered in this particular session. So first one, we are going to see the definition. Next, we see the classification of the distribution system. And the next one, we are going to see the distribution system losses. These are all the things which you are going to see in the coming class. So now coming to the exact definition of the distribution system. So here already previously, it is just now I told you what exactly the distribution system is going to be. So here the part of the power system which distributes the electrical power for local use is known as the distribution system. So here whatever the part of the power systems are having various parts, like generation is there, we can say one part, and transmission is there one part, distribution. So these are all the various parts we can say. So that part of the power system which distributes the electrical power for local use. So whatever the part of the power systems that distributes the power for local use, that we are calling it as a distribution system. So here already discussed this one. So that part of the system which is there between the transmission system as the consumer meter. So whatever the part of whatever the electrical system that is there between the transmission system as well as the consumer meter, that we are calling it as a distribution system. So distribution lines, if you see distribution lines, generally what it consists of. So generally distribution lines are going to consist of feeders, distributors as well as the service mains, right? The distribution system is mainly consisting of what? Feeders, distributors as well as the service mains. So now you can find again the diagram. So distribution means what here? So distribution is nothing but feeders, distributors as well as the service mains. So you can observe there in the diagram from the distribution system what is happening. So feeders are coming outside. So from the feeders, what is happening? Again, the distributors are carrying the power. From the distributors, if the bulk loads are connected to the system, so from the directly distributor, the power is given to the bulk loads, or else by means of the service mains, the power is given to the consumers. So this is the element. These are all the elements of the distribution system. Now, so coming to the definitions which you are using in the distribution system. So first one is a feeder. So what is a feeder actually? So feeder is a conductor which connects the substation to the area where the power is to be distributed, right? So the feeder is nothing but it's a conductor. So it's just like any other conductor, feeder is also a conductor. So what it is doing, it is connecting the substation from the substation to the area where the power has to be distributed. That conductor is called as what here? Feeder, right? So feeder is a conductor which connects the substation to the area where the power has to be distributed. So that is called as a feeder. Now coming to the feeders, generally used for the feed the electrical power from the generating station to the substation. Okay? So whatever the conductors that are there being used for distribute the electrical power from the generating station to the substation. So the main thing in the case of the feeders is that the current is going to be maintained as a constant. So in the case of the feeder, the current is always maintained as a constant because on the feeder there are no tappings are there. That means so on the feeder we are not going to tap the feeder. Tapping means what? So tapping means by whenever we are tapping that one, what is happening? The current gets distributed. So here, if you take the feeder, so no tappings are taken from the feeder. That is the feeder designing. So main consideration in the design of the feeder is that current carrying capacity. So since you are not, what you can say, you are not tapping the feeder, so the current is going to be maintained as a constant. So that's why while designing the feeder, we are going to consider the current carrying capacity. So we are going to consider the current carrying capacity. So that is about the feeder. Next comes the distributor. So what is a distributor? So a distributor is also a conductor. So just like the this feeder, a distributor is also conductor. So which are taken from the pole mounted transformer to the consumer. So whatever the conductors that are taken from the pole mounted transformer to the consumer, so that conductor we are calling it as a distributor. So the current to the distributor is not constant because tappings are taken from various places along its length. So if you take the distributor, the current through the distributor is not maintained as a constant, because what we are doing, we are going for the tappings. So whenever we are going for the tappings, what is happening? The current is not maintained as a constant. So here, so voltage drop is main consideration. So in the case of the distributor, voltage drop is a main consideration. That means while designing the distributor, we see the voltage drop. Whereas if you take the feeder designing, we see the current carrying capacity. If you look at the distributor, voltage drop is a main consideration. So limit of variation is 6% of rated at the consumer voltage. So here, whatever the variation is there, that is only the 6%. Next comes the service mains. So what is a service mains? So service mains is generally a small cable which connects a distributor to the consumer meter. So whichever the cable which connects the distributor to the consumer meter, so it's nothing but the service mains. So the connecting links between the distributor and the consumer terminals. So other name for the service mains is what? These are the connecting links between the distributor and the consumer terminals. So again, we have one more diagram there. So you can find in the diagram. So what is happening from generating station or substation? So the the conductors are coming outside, which are called as the feeders. So on which you find that there are no tappings are provided. So you find that's why toward the feeder, the current is going to be the same. And again, from the feeders, the power has been given to the distributors, and from the distributors, the power has been taken by the service mains. So that is a diagram which indicates the exact transferring of the electrical energy. Now, so again, one more diagram which indicates the flow of electrical energy. So from that in the diagram, so you can observe that generating station is there, a substation. So what is happening here? So from the generating station substation, feeders are coming outside. So one feeder is going for feeding points, and other feeders are coming and feeding the substations. And from the substations, what is happening? Distributors are coming outside, and these distributors are giving the power to the consumers by means of the service cables. You can find in the diagram the consumer premises they connected the service cables. So this is a flow of the electrical energy. Now, so you can again one more diagram is there. So where you have the substation. So from the substation, feeders are coming outside, and the feeders are giving the power to the distributor, and the distributors tappings have been provided, and these tappings are giving power to the consumers through the service mains. So again, we have the one more diagram how the voltage levels have been stepped down. So here, right. So first one is the transmission tower. So this transmission tower will handle a voltages of what? 800 kV, 400 kV. So these voltages generally we are calling it as the extra high voltages. Next, the voltages again they have been transferred through the transmission towers to the substations. So here in this one substations, the power is received at a voltages of 220 kV or 132 kV. So here in the substations we have the step down transformers. So those step down transformers will step down the voltages from 220 kV or 220 kV or 130 kV to 33 or 66 kV. So you can observe the diagram where the voltages coming outside are having a 33 or 66 kV. Again, this voltage is again fed to the 33 kV substation. So in this one, again the voltage has been stepped down to 11 kV. right? So here, in again 33 kV substation, the voltage have been stepped down from 33 kV to 11 kV. So this 11 kV feeders are also called as a distribution network. Again, this 11 kV is again fed to the distribution transformer. So from in this distribution transformer, generally it will be on the pole where the voltage again is fed to step down to voltages of 415 kV. So here this 415 kV are given to the consumers. So if the consumer is having a very high voltage, high loads, then he requires phase supply. So that's why we say 415 volts. And similarly, if the consumer is having a less loads, you can have the single phase supply 240 volts. So this is how the voltages have been stepped down to the consumer till it reaches to the consumer. Is everybody following?
Yes, sir.
Right. Right. Now coming to the next one. So here again the same diagram is there. So here in the generating station we have the this thing steam turbine, generator, everything is there. So again that is being given to the transformer, and again from the transformer, transmission line, substation. So all previous stuff only. So distribution system. So here that part of the system. So what is distribution system means? It is a part of the power system existing between the distribution substations as well as the consumers, right? So whatever the part of the system that is there between the distribution substations as well as the consumers, that is called as a distribution system. Again, this is again further classified on the basis of the voltage. So on the basis of the voltage, how we are classifying this one? So primary distribution system and the secondary distribution system. So primary distribution system voltages are 11 kV or 6.6 kV or 3.3 kV, and the secondary distribution system voltages are 415 volts or 230 volts. So here again classification is there. So we can classify the this particular distribution systems on many bases. So first classification is on basis of the type of the current. So what type of current that the distribution system is carrying. So based on that one, so we can divide the distribution system into AC distribution system or DC distribution system. Similarly, type of the construction. So based on the type of the construction, we can classify the distribution system into overhead system as well as the underground system, right? So type of construction we can classify into overhead system and underground system. Overhead system means what? So whatever the system that we are observing in our daily life, that is all the conductors, poles, all those things will be on the surface of the ground. So that will be that we are calling it as a overhead system. Underground system means in some places where you find that the what you can say the overhead system will is going to damage the beauty of the location. So in those areas, what we do is we prefer to have the underground system rather than the overhead system, right? So underground system is only chosen where the beauty of the locality is getting damaged. So where you find that if all the conductors are being outside, so that damages the beauty. So in those cases, we go for the underground system. The next classification is on the type of service. So what type of service the distribution system is doing. So based on that one, we are classifying the distribution systems as general lighting and power, industrial power, railway, and street lights. Similarly, based on the number of wires, we can classify the distribution systems as 2-wire, 3-wire, 4-wire system. Similarly, based on the scheme of connection. So based on the scheme of connection, so we are classifying the distribution system as radial distribution system, ring or loop distribution system, and interconnected distribution system. So this is based on the scheme of connection. And coming to the AC distribution system. So here, AC distribution system is nothing but what here. So it is the electrical system between the substation, step-down substation fed by the transmission system and the consumer meters. So whatever the electrical system that is there between the step-down substation as well as the consumer meters, so that we are calling it as a AC distribution system. So in this AC distribution system is again classified into primary distribution as well as the secondary distribution. So this AC distribution system is again classified into primary distribution system as well as the secondary distribution system. Right. So coming to the this primary distribution system, any doubts so far?
No, sir.
No, sir.
Totally?
Yes, sir.
How many students are there totally? 10, sir. Right. Listen carefully. So here primary distribution system. So here the primary distribution system is nothing but here. So in this distribution system, whatever the voltages that we are carrying, so that will be somewhat higher than the general utilization levels. So here, what this primary distribution system will handle the voltages which are generally higher than the general utilization. So commonly the primary distribution voltage will be what? 11 kV, 6.6 kV or 3.3 kV. So these are the generally used primary distribution voltages. So here and similarly, so what is exactly primary distribution means? So electrical power from the generating station is transmitted at high voltages to the substation located near our city. So at the substation, what is happening? The voltage is stepped down to 11 kV with the help of the step down transformers. Okay. So from the generating station, the electrical energy is transmitted at a high voltages to the substation. Right. So again at the substation, what is happening? Voltage is stepped down to 11 kV with the help of the step down transformer. Again, what is happening there? So the power is supplied to various substations for distribution or big consumers. So this at the substation. So what is happening? The power is supplied to the various substations for distribution or big consumers. So from the substation, either the power may be transmitted to the other substations or directed to big consumers. This forms the high voltage distribution or primary distribution. So whatever the distribution system that is there here, that is uh, delivering the power to the various substations or big consumers. So what are the distribution system that is there, that we are calling it as the primary distribution system. And similarly, we have the you can find the diagram there, the primary distribution. So you can find that diagram. So what exactly the primary distribution system is. So from the substations, the power is given to the other substations, or from the or else it is given to the big consumers. Whatever distribution system that is there, so that we are calling it as the primary distribution system. Similarly, we have the secondary distribution system. So this secondary distribution system is nothing but that part of the AC distribution system which includes the range of voltages at which ultimately uses the electrical energy. So whatever the distribution system that is being used by the consumer, that is called as a secondary distribution system. So generally the secondary distribution system employs a 400 by 230 volts. Okay, the secondary distribution system employs a 400 by 230 volts voltage levels. So in the diagram, you can find the secondary distribution system. So what is happening is the electrical power is being given to the what you can say from the distribution system to the houses. So that part of the system we are calling it as the secondary distribution system. So DC distribution. So DC distribution is nothing but here. So DC power is required for a variable speed machinery. So if you see whenever we require the variable speeds, so in those cases we make use of the DC power supply. So we are going to make use of DC motors. So that we are calling it as a DC distribution. So for this purpose, what we need to do is we need to convert the AC power to DC power at the substation by making use of the rectifiers, right? So where the consumers whichever require DC power. So for that purpose, what we are doing is in the substation itself, we are converting the AC power into the DC power by making use of the mercury arc rectifiers and the motor generator sets. And so here the DC power may be obtained in two ways. The DC power from the substation may be obtained in the form of 2-wire or 3-wire for distributor. Okay, so this is a 2-wire or 3-wire distribution system. So with this, I'll stop the class today. Wait a minute.